Hi students, in today's video we are going to discuss about phasing concept. First of all, sorry for this unnecessary noise. Let's move to our topic. Okay, uh, we are just reading a paging concept. Okay, you have to first understand some components in our paging concept. That is, first component is our main memory. Okay, then our virtual memory. Okay, virtual memory often maintained by our OS. Okay, then page table base register, then page table length register, then TLB. Okay, let's first discuss that. Wait, there is something other things you will be introduced. That there is something called pages and frames. Okay, first of all, let's discuss what is frames. Okay, the main memory, this is our main memory, physical memory. This main memory is divided into a fixed size blocks. Okay, these blocks are called frames. Okay, these are frames. Okay, and then what is pages? Okay, first of all, there is a virtual memory which is maintained by our operating system. Okay, the virtual memory is on another side. Okay, I am just erasing this part. Okay, okay. Here is another memory which is our virtual memory. Okay, this is our virtual memory. Okay, in the virtual memory, the size of the block in the main memory is exactly the same as the virtual memory block size. Okay, so both the blocks have same size, and here the block called frame. Okay, and here the called page. Okay, now it's easier to distinct. Okay, then this is actually a non-contiguous memory allocation. So here is some part and here is some part. In actually, in our physical memory, okay, in our physical memory, there are actually the data of the process are in a different location. Okay, but this is the virtual memory. Here is some another things happening in the virtual memory. Okay, let's discuss that this is the uh, this is the part one of the process loaded, then part two loaded, then part three loaded. Actually this is this does not exist, but this is a imaginary memory mentioned by our operating system. It is our logical address or virtual address. Okay, then what happening? Okay, here is actually a table called page table. Okay, page table. Here is our page table. What will be mentioned? That here is our frame. Here is our page. Okay, means which page have which frame number. Okay, which page has which frame number. Let's again discuss. Here is a table. Okay, this is the table, and here is one is page and another one is frame. Okay, and let's discuss that our process P1 have three pages. Okay, page 1, page 2 and page 3. Okay, and let our page 1, let's I'm dividing just 1, then 2, then 3, then 4, then 5, then 6, then it's 7. Okay, 7, then here is, okay, it is 8, then 9, then 10. Okay, 10 have some data of the process. Then we have 3 frames, 4, 7 and 10. Okay, then but here is mentioned that 3 pages, 1, 2, 3. and the frames associated with are 4, then 7, then 10. Okay, is that clear? Okay, the page table actually mentions the page number. Okay, the page number and the page number associated to the number frame number means in which frame of the main memory the process data is existed or data is stored. Okay, then here is another component called MMU. Okay, MMU, very crucial thing, MMU. Okay, memory management unit. Memory management unit. Okay, the memory management unit actually when the CPU sends the data or requests the data, first the memory management unit convert the address from the CPU. Actually the CPU send the logical address. Okay, the conversion take through the memory management unit. Okay, or the memory management unit took the help of page table. Okay, then convert the address, logical address, to the physical address, then we get our data from the physical address. Okay, these are the simple concept of paging. Okay, and I have also mentioned some other components like our PTBR means page table base register. Okay, page table base register holds the address of the page table in the main memory. Okay, uh, you have to just clear that the page table also in the main memory. Okay, there is also a space allocated for the page table to be stored. The page table to be stored in the main memory. Okay, the page table will be stored in the main memory, and the page table's address in the main memory is stored to the page table base register. Okay, there is another register called page table length register. Okay, page table length register keeps the page table data, like how many indexes you have, the length of the page table, or the information regarding the page table held by the page table length register. Then another register called TLB, translation Lookaside buffer. Okay, this is a buffer just works like our cache memory. It keeps the regular use page and frame numbers in the translation Lookaside buffer. Okay, it just works like our cache memory. Okay, these are the concept of paging. Very much simple, nothing complex. Okay, you have to I'm just mentioning the components again. First component is the main memory. Okay, and then second component is virtual memory. Okay, and then our memory management unit, then our page table base register, then page table length register, then our translation Lookaside buffer. Okay, these are some parts of our paging concept. Okay, here is some points. Okay, I am reading these points. If I skip some points, I will make it clear. Okay, main memory is divided into a number of equal size blocks are called frames. Okay, main memories are divided into equal size blocks called frames. Each process is divided into a number of equal size block of the same length as frames. Okay, are called pages. Okay, what do you mean by that? I am repeating again. This sentence means that the operating system maintain a virtual memory. Okay, a virtual memory. Okay, then let's discuss. This is not a virtual memory, but let's discuss like OS. What OS do? OS maintain its separate memory. Okay, separate memory means separate list of data or list of processes which are executing or will be executed. Okay, in this virtual memory. Okay, the virtual memory has also divided into some parts and fixed size. Okay, the frames are equal to the pages, means the virtual memory are divided called pages, and the pages of virtual memory is same size as the frames of main memory. Okay, a process is loaded by loading all its pages into available frames. Okay, a process is loaded by loading all of its pages into available frames. Okay, a may not contiguous, means there is not contiguous manner is not followed. The frames are maybe in, okay, irregular or on non-contiguous manner, just as you looking here. A frame is here and another frame is here, related to or associated to the same process. Okay, then here is our process translation from logical to physical address. It takes place through our memory management unit. Okay, don't skip memory management unit, you have to mention memory management unit in your semester exams. Okay, every address generated by the CPU is divided into two parts: a page number and a page offset. Okay, now just he's clarifying the diagram. Let's move to our diagram. Okay, a CPU sending our page and D means our block offset, means look, this is a block. Okay, in the block, uh, there are several instructions. Okay, the D means the block offset, means the number of the instruction number. Okay, means there are maybe 16 instructions. We have just representing 16 like 0 0 0 0 to 1 1 1 1. Okay, uh, is just asking about the 14 number instruction. Then what will he do? He just 1 1 then 0 1. Okay, this is our 14 number. Okay, uh, check it. Okay, like this. Then here is our logical address, in which here is our page address and here is our instruction address. Okay, then we are moving to our page table. Then we are just looking the page number, then which page is associated to our which frame. Then we are finding the page frame number, then in which frame we are going and finding the instruction number from that frame. Okay, this is what happened in the paging concept. Okay, here is our the page table contains the base address of each page in physical memory. Okay, I have already told that the page table base register. Okay, it holds the address of the page table, and the page table is also in the main memory. Okay, it holds the main memory address. Okay, then address is combined with the page offset to define the physical memory address that is sent to the memory unit. Telling about this. Okay, we are just using this and finding the instruction number. Okay, if the size of logical address space is 2 to the m and the page size is 2 to the n, in addressing unit, then the high order bits of logical address designate the page number, and the n low order bits designate the page offset. Okay, nothing like that, telling that m is the maybe m is the higher order, then m is our page number or page number, then if n is the lower order, then it will the instruction number. Okay, okay, here is some example. You can read the example for more clarity. Okay, here is some hardware support. Okay, implementation of page table paging hardware like TLB. Okay, what is TLB? Translation Lookaside buffer. I have just mentioned about translation Lookaside buffer. Let's move something more. First, reading the hardware support for paging. Each operating system has its own method for storing page table. Most operating system allocate a page table for each process. Okay, what is it telling? Each process have different separate page table. A pointer to the page table is stored with other register values like in the instruction counter in the process control block. Okay, in the PCB, a pointer towards the page table is stored When the dispatcher is told to start a process, it must reload the user register and define the correct hardware page table values from the stored user. Okay, and nothing to say, nothing to clarifying this. Dispatcher. What is the work of dispatcher? Mainly the dispatcher do the scheduling task. Okay, there is schedulers, but the dispatcher do the scheduling. Okay, then he's just telling that from the PCB and uh, the dispatcher, okay, linking to the PCB and operating and executing the operations. Then implementation of page table. Okay, generally page table is kept in main memory. The page table base register here mentioned points to the page table. Okay, what is telling, a page table based register are pointing towards the page table in the main memory. Okay, page table length register indicates the size of page table. Okay, in this scheme every data instruction access required to memory access, one for the page table and one for the data instruction. Okay, then the two memory access problem can be solved by using of a special fast lookup hardware called associated memory or translation Lookaside. Okay, what is telling, we are just going repeatedly to fast checking the page table, and then from the page table we are finding the frame number. Okay, we are repeatedly doing this task, to not repeatedly doing this task, just doing the choosing the shortest path by translation Lookaside buffer. Okay, translation Lookaside buffer just keeps the repeated or frequently used page table frame number in it and helps the paging concept. Okay, and today that much for today's video, and thank you.